In this lesson, we're going to talk about another type of sequences. We're going to talk about geometric sequences. All right. So geometric sequences are different than arithmetic sequence because of the fact that for a sequence to be geometric, you need to take one term and you have to multiply the previous term in order to get the next. And we call that a common ratio. We call that a common ratio R. It is what we multiply by to get from one term to the other. Remember, arithmetic, you had to add. In geometric sequence, we have to multiply to get from one to another. So we can determine whether a sequence is geometric by trying to figure out, is there a common ratio from one term to another? So in order to find a common ratio, what you have to do is you have to take a term and divide it by the previous term. So in this case, we take 63. So we take 63 and divide it by 21. You have to take 189 and divide it by 63. You have to take 567, divide it by 189. And if you do all of that, you're going to get 3. That means that your common ratio is 3. And since all of them are exactly the same, that would make this a geometric sequence. So you just have to make sure that there's that constant common ratio that you multiply by to get from one to the other. You can do the same here in example 2. All right, so it says find the next 3 terms. In order to find the next 3 terms, you're definitely going to have to find the common ratio first. So you take the terms of 4. Okay, so it told you that it is a geometric sequence. So all you have to do is actually do this once. You could just take the 405 divided by negative 1215, reduce it down and get negative 1/3 to find your R value. You would then take that R value, take the 45. So that 45 was the last term we knew. Okay, and you would keep multiplying by that negative 1/3 over and over and over again. There's supposed to be a negative in here. You would keep multiplying by negative 1/3 to get your next 3 terms. Let's see what this looks like with examples. Okay, so to determine whether it's arithmetic, geometric, or neither, we have to take a look at this. How do you get from 1 to 2? Well, you could think about it like I have to add 1, right? Well, how do you get from 2 to 4? You would add 2. So since that's different, it's definitely not arithmetic. Well, how do you get to 1 to 2 by multiplication? You would multiply by 2, right? Well, how do you get from 2 to 4 with multiplication? You would multiply by 2. How do you get from 4 to 8? You would multiply by 2. So this is geometric with an R value or a common ratio value of 2 because that's what you're multiplying by. Okay? So let's think about the next one. How do you get from 9 to 14? Well, you can add 5. How do you get from 14 to 6? Well, you would have to subtract, right? You would have to subtract 8. So it's definitely not arithmetic. How do you get from 9 to 14 with multiplication? Well, you can write that as taking 14 divided by 9, so taking a term and dividing it by the term before. The question is, does that equal to 6 divided by 14? And the answer is going to be no. They're not equal to one another. So this is neither. Because there is no common ratio and no common difference. Okay, so let's try 3. To get from 2/3 to 1/3, you have to subtract 1/3. If you subtract 1/3 from 1/3, that's going to be 0, so it's definitely not arithmetic. So then the question becomes, how do you do this geometric piece? Well, think about this. If you half this, right? If you multiply 2/3 in half, if you have 2/3, half of 2/3 is 1/3. So you would have to multiply by 1/2 to get here. How do you get from 1/3 to 1/6? That's actually the same idea. That'd be half of it. So we're multiplying by 1/2, multiply by 1/2, and that would make this geometric with a common ratio of 1/2. I'm going to skip 4, and I'm going to ask you to do that in some of your practice. Find the next 3 terms of the geometric sequence. So the first thing we want to do is figure out what the common ratio is. So you can take any term and divide it by the term before to find the common ratio. So our common ratio, I'm going to take, let's take 216 and negative 216, and divide it by 648. We're going to reduce, and this is going to be negative 1/3. So we are going to take each of these here, all right, and we're going to take the last term and we're going to multiply by that negative 1/3. Okay, so we look at 72 and multiply by negative 1/3, and you're going to get negative 24. Multiply that by negative 1/3, you're going to get 8. And you multiply that by negative 1/3, and that's actually going to not turn out to be anything very nice. I'm just going to leave it as negative 8/3. Okay, we are going to try 7, and I'm going to leave the other 2 for you. So I'm going to take my r value and say I'm going to take some term 4 and divide it by the term before it, 1/2. 4 divided by 1/2 is the same thing as saying 4 divided by 0.5 if you want in your calculators, and that's 8. We could look at, there's a method called keep, change, flip. You keep the 4, keep the numerator, change the division to multiplication, and flip the fraction on the bottom, and that helps us get a common ratio of 8. So if we look at the next 3 terms, we take 4, multiply it by that common ratio of 8, you get 32. Multiply 32 by 8, you get 256. Multiply that by 8, and you get 2048. So you want to find the common ratio first, multiply that by the last term, and keep going until you find the next 3 terms. You'll try 6 and 8 on your own. Let's look at the next page. So to find the geometric sequence, the common formula, or a formula to find the nth term of a geometric sequence, we've done something like this with arithmetic sequences. A little bit different though. So for geometric sequences, you need to figure out our formula here. So our formula is a sub n is equal to a sub 1, which just means our first term, times r, which is our common ratio, raised to the n minus 1 degree. Okay, so we need to figure out the first term and what's the common ratio in order to figure out our formula. All right, we have an example here. Write the nth term for the geometric sequence of 5, 20, 80, 320, right? How do you get from 5 to 20? Well, you would multiply by, since it's geometric, we're talking about multiplication, you would multiply by 4, right? So our r value is equal to 4. This should be not 3 there, it should be 4. Okay, so our r value is 4. Our first term is the 5, that's a sub 1. So we can take that general formula that's down here, I've underlined, and plug in our first term and our r value. We knew our first term was 5 and our r value is 4. So this would be the general formula for a geometric sequence. In order to find the 7th term, that means n is equal to 7. N just means the term number. In order to find the 7th term, we're going to take exactly what we just found. So we're going to take the 5 times 4 raised to the n minus 1, but this time we know that n is equal to 7. So we plug in n is equal to 7. So it's really 5 times 4 to the 7 minus 1 power, or to the 6th power, right? And we can calculate that, put that in our calculator, and find that the 7th term would be 20,480. All right? A little bit easier than keep having to multiply over and over and over again. I guess 7 isn't so bad. All right, so let's get some practice. We're going to do 2 of these and then leave the rest for you. Okay, once again, let's rewrite the nth term formula, that general formula. A sub n is equal to the first term times our common ratio to the n minus 1 power. So the first thing we need to recognize, what do we need to multiply to get from negative 2 to 10? You could say this, take 10 and divide it by the negative 2, divide it by the term before to figure out that our common ratio is negative 5. Our first term that we have is negative 2, so we plug that in. We say our a sub n is equal to negative 2 times our r value is negative 5. I'm going to put in parentheses because all of the negative 5 gets raised to the n minus 1 power. Okay, in order to calculate this here, what we're going to want to do is to figure out the 11th term. That means we're going to figure out when n is equal to 11, we're going to plug in a sub 11 is equal to negative 2 times negative 5 to the 11 minus 1 power. So we want to take negative 5 to the 10th power, really, right? So this is negative 2. Let's rewrite it at times negative 5 to the 10th power. Okay, So let's take a look at that. If we take -5, raise it to the 10th power, that's going to be quite a big number, times -2. We're going to get 19,531,250. Right? Quite a big number, but that's okay because our formula made that a little bit simpler for us, and plugging it into a calculator isn't so bad. All right, let's try another example. Let's try 11. So with the fraction, to find my common ratio, all you need to do is take any term and divide it by the term before. So I wouldn't take 4 divided by 4/9 just because you're going to get a complex fraction or a fraction within a fraction. So instead, what I would do is I would take the 36 and divide it by 4 and say, all right, my common ratio is 9. My first term is 4/9. And I'm going to plug that into that general formula that we had above, which is our first term, which is 4/9, times our common ratio, which is 9 raised to the n minus 1. And we want to find the 8th term. So we're finding when n is equal to 8. So a sub 8 is equal to 4/9 times 9 to the 8 minus 1 power. Let me zoom in here for us. In 8 minus 1, we can easily simplify. So 4/9 times 9 to the 7th power. This is going to be quite a little bit here. So we take 9 to the 7th power, and we multiply it by the 4/9. And we get our 8th term is 2,125,764. Okay, so it's the same type of process the whole time. Identify what's the first term, find the common ratio by taking any term, divide it by the term before, okay, and then plug it into that general formula and work backwards and use the general formula eventually. Okay.